All right, so Unit 10, last unit. Um, this unit, what we're going to be doing is we're going to be talking about comparing two numerical variables. And so for today, what we're going to be doing is we're going to be displaying relationships with scatter plots. Real quick though, here's a little bit of vocab. So what I want you to do is just pause your video, take a second to look over these. Okay, so we've got question here. It's asking us about golf. Now, one of the questions that a lot of golfers have are, should I hit the ball really hard and get it closer to the tee but risk going off the green? Or should I ease off a little bit, be a little bit more accurate, ball doesn't go as far, but I know I'm going to land in the green. So here's the tee box, and then here's a hole that they're trying to get it to. I could hit it really hard and veer off into the hazard somewhere. Or I could ease off a little bit, hit a little bit shorter, but I know I'm going to land in the green. Okay. And so what we have is we have the top 10 money winners for the LPGA Tour in 2009. And we're comparing their average driving distance and their driving accuracy. And we want to see if there's a relationship between these two numerical variables. And the way we're going to do that is we're going to represent it using a scatter plot. And so here we have the directions on how to make a scatter plot by hand. Here in a second, I'm going to show you how to do one on a calculator. But first thing it wants us to do is label our X and Y axes. So I'm going to create a graph, X and Y axes. And what I'm going to do, I'm going to have average driving distance be my X value and average or driving accuracy be my Y value. And I got to label these axes with numbers, right? So I want to see what's my smallest average driving distance and what's my smallest and biggest average driving distance and smallest and biggest accuracy. So I know what range I need to be. So my smallest average driving distance is 245.7 and my largest is about 269.2. So my numbers are ranging from about 245 to 270. So what I'm going to do, since this is my X value, I'm going to make this axis, the X axis, my average driving distance. And so I'm going to have, since my numbers range from 245 to 270, I'm just going to start 245, 250, 255, 260, 265, 270. And you can do whatever scale you want. I'm just doing these because those are nice round numbers and they're easy to write. And then for my y-axis, my smallest value looks to be about 6.654 and my largest is 0.824. So from about 0.65 to 0.825. So I'm going to do 0.65, 0.7, 0.75, 0.8, 0.85. Okay. And I need to label them too. So x-axis is average driving distance. And these are in yards, by the way. And then driving accuracy. And whenever you're thinking of driving accuracy, that just means their percentage chance of getting on the green. So Jai Shin, she hits the green about 82.4% of the time. That's all that means. And all I want to do is I want to put a dot for each of the people. So 246.8 to 824. So that's about right here. Okay. 265 to 718. So I've got about 265 to 718. It's about right here. And then 254.3 to 757. 254.3 to 757. 263.7 to 714. 255.5 to 733. I've got 268.1 to 66. 269.2 to 654. 249.3 to 748. 248.6 to 811. And then last one, 245.7 to 770. So, all right, there. So I've got a dot representing each player, and you can see it's kind of going downwards, right? Kind of going down like this. We're going to talk about that here in a second, but I just wanted you to notice as we go along our graph, it starts to go downward. And so this right here is directions on how to do it on a scatter plot on your calculator. And so what I've got is I've got my calculator pulled up here. Okay. And it tells us enter the explanatory variable into data into list 1 and response into list 2, and then open the stat plot menu by pressing second y equals and choose plot. So what I'm going to do is I'm going to pause the video real quick. I'm going to input my data and I'll come back whenever I'm done with that. So what I did was I took all of my average driving distances and I put them in list 1, and then I put all of my driving accuracies and put them in list 2. And then the next step, what we need to do is it says open the stat plot menu by pressing second y equals. So I'm going to hit second y equals, and it says choose plot 1. So it's already got plot 1 highlighted, so I'm just going to hit enter. And then it says turn it on, choose the first graph type, and enter list 1 for the X list and list 2 for the Y list. So I need to turn it on and then type what I need to do, X list and Y list. It didn't tell me to do anything for type yet. And then mark and color, those just tell you, mark just shows you what the dots will look like, and then color just tells you what color you want them. Oh, I'm sorry, yes it did. Choose the first graph type, so it's already highlighted for us, so we don't have to do anything there. And then part 3, it says to see the scatter plot in a nice window, press zoom, and then select 9 and press enter. So what you can do is hit zoom up here at the top, and then just press the number 9. And then boom, it gives us our scatter plot in a perfect viewing window. Unfortunately, it doesn't label the names or put numerical values on the scales, but you can still see the overall trend of the graph. And it says after constructing a scatter plot, there are several important characteristics about the association between the variables that should be considered. So I'm going to go back to just viewing this. All right, so the top 3 things of a graph, whenever we're describing a graph, we're going to be describing the direction, the form, and the strength. These are the 3 descriptors of a scatter plot. And so the first thing is the direction. So there are 3 types of direction that a graph can have: negative, positive, or no association. So a negative graph, we always read these from left to right. Negative graph goes downward in a negative direction. Positive goes upward in a positive direction. And no association would be something like if these 2 dots weren't here, these 2 circled dots, these are kind of throwing it off to where it doesn't really have any association. It's kind of in the middle. If these dots weren't here, it would definitely be more towards positive. So a graph that really doesn't have any association just has dots scattered everywhere. There's nothing gluing them together. They're just kind of floating around. So positive is upward, negative is downward. No association would be dots scattered everywhere. Next thing is the form. So there are two types of form that we have, linear and nonlinear. Linear is just like it says, it follows a straight line. And then nonlinear, see how these kind of curve downwards? Majority of the graphs we're going to be looking at are linear in shape or form. And then the last thing is strength. How strong of a relationship do these graphs have? So very strong. Everything's pretty much almost completely in a straight line. And then the farther down the list you go, the weaker it becomes, the more scattered they are. So this one's a little bit more scattered, a little bit more scattered, and then really scattered. Though the direction is still upward. Even on this weak graph you see here, it's still positive direction, though the strength is not really there. And then so if you compared these two graphs, average driving distance and driving accuracy, to shooting average, or excuse me, scoring average, you can see that average driving distance and driving accuracy are both negative in association, but it looks like average driving distance is a little bit stronger of an association than driving accuracy. So from here on, the rest of the Nearpod, you're going to be doing this one on your own.